This is a tutorial for building a digital counter circuit, and this is also going to be a guide for how to properly use a breadboard. We're going to be building this circuit. Eventually we're going to connect it to the MyDAC to generate the clock signal into the counter, and have a start-stop control that'll start and stop the counter, and also a reset to reset the counter to 0, and the counter's binary value will be displayed on 4 LEDs. But the first part of this, we're just going to build the hardware part and use a push button to make the count. So these are the components you're going to need. We've got a push button, a 0.1 microfarad cap, a resistor, 5.6K, 6 LEDs. Mine happen to be blue because they show up nicely, but it doesn't matter, any color will work. And every LED needs a current limiting resistor, so there's 6 resistors here. You're also going to need some tools. You need a set of wire cutters, also a wire jumper kit. Yours might be smaller than this, but should have all the different sizes. And if you run out of jumper sizes, you can always make some by stripping an end and cutting it. But if you can, it's always best to use the pre-cut jumpers. You're also going to need a MyDAC, a protoboard, MyDAC protoboard, which we're going to use to build the circuit, and a USB cable for connecting the MyDAC. And also, we're going to do some testing, just some measurements of voltage. So you're going to need some meter leads, and if you have one of these are great. These are called easy clips, and it allows you to clip into the circuit, and then you can just use one probe, keeps your hands free. All right, so let's get started. Okay, so the key to good breadboarding is, number one, make short, direct connections whenever possible. Number two, take your time and build and test one section at a time. So the first thing we're going to do is connect the 5 volts and ground from the MyDAC, which is here, over to these power bus lines. The long one with the red stripe we're going to use for 5 volts, and the blue stripe we're going to use for ground. And we're going to connect them on both sides of the board. So we need, for the ground connection, I'm going to use one of these brown jumpers. Just do it down here. And for the 5 volt, I'm going to use a white jumper, just because they're cut to the right length. Color is not important. We also need to jump from this side to that side of the board. So for the 5 volt line, I have a red jumper. Color is not that important, but generally we use red for 5 volts and black for ground. In this case, I'm using a green jumper. Okay, now remember, this is going to be plugged into the MyDAC, and that's where the voltage is going to come from. But once we plug it in, we should have 5 volts on the red line and ground on the blue. Next, we're going to connect the inverter, which is the 74LS14, and that's right here. I'm just going to plug that into the breadboard. Now, what you don't see on the schematic is the power pins. The only thing that's shown is the input and the output of the inverter. To find the power pins, you have to either go online or look this up in a data sheet. So this is showing the 74LS14, that the power pins are pins 7 and 14. If you hold it this way, that's the way the chip is oriented. So that means pin 14 has to go to 5 volts and pin 7 to ground. So I'm going to use an orange jumper just the right length to jump across to ground. And then on the other side of the board, pin 14, actually looks like another orange jumper, does the trick. So now the chip will have power. Now we're going to connect the push button and the capacitor. So the push button looks like this. And if you look at the schematic, pin 1 from the inverter connects through the push button to ground. Now, the pins aren't quite wide enough to jump directly from the pin over to the ground line, so I'm going to jump it. I'm going to go up. I'll show you what I'm doing here. I'm going to jump up to this run and then make a jumper to jump that down to ground. Okay, so that push button is connecting pin 1 to ground. Now we need to put the capacitor in parallel with it. So we just make sure we connect it to the same 2 points right next to it, just like that. The only other thing we need is the resistor. So that one is the 5.6K resistor. Now, oops, that's not the right one. Here it is. Now, when you put a resistor in a breadboard, what I don't recommend is keeping the leads long, so you've got this big, tall resistor that's kind of all these exposed metal legs. And so you should cut it down. And I'm going to make this jump from here to 5 volts. So I'm going to cut the leads down a little bit. That length. And jump that over to 5 volts. All right. So I've just made, now I have a highlighter here, and this is a good idea as you make the connections to highlight them. So I've made the connection from the resistor to 5 volts, from the pin 1 of the inverter to the push button, from that same location to the resistor, to the capacitor, and these are both connected to ground. So I'm going to add one thing to this because when I test it I want to get a visual. So I'm going to add the LED and the resistor to the output of the inverter. Now the LED also has some very long legs. Another thing about it is, if you look at it, one side of the LED has a flat, whoops, that's a lot of focus, okay, there we go, a flat section on one side of the LED. So that's the negative pin. That's the one that's the cathode that goes toward ground. So what I'm going to do is, I want this pin 2 to connect to the LED, but I'm going to put it into the circuit down here, and then run a jumper down to it, and that way I can have the LED plugged in with just the short leads in this point. So right now it's too long. I'm going to cut the leads down to just about that length is good. And make sure I know which direction the cathode is pointing. Okay, now I need to run a jumper from pin 2 down to the anode of the LED. And there's 1, 2, 3, 4, 5, 6 spacing. lines. So these jumper kits are kind of cool. The sizes of the jumpers are in order, and they actually follow the resistor color code. So this is 1 space, 2 space, 3, 4, 5, 6. So I need a blue jumper to go 6 spaces on the breadboard. I'm going to get the LED out of there while I do this because I can't quite get my fingers in there. All right, so there's the blue jumper down to there. Here's the LED. And the last thing I need is a resistor from the LED cathode to ground. So let's do that. We're going to use a 1.8K. Actually, I couldn't find any 1.8s. I'm using 1.5s. Close enough. The purpose of this is to limit the current through the LED. Okay, I'm going to cut the leads down again. We'll just plug it into the breadboard. Okay, so that's the resistor going to the ground lead. Now, so this is the point where we should stop before we go any further. Actually, let me highlight these. So I just made this connection to the LED, and the LED to the resistor, and the resistor to ground. So we just need to test that. We want to make sure that when we push the push button, the LED blinks on and off, and that will mean we'll have a good clock signal, and then we'll start building from that point.